Hey folks, good to see you. Ready for our homework demo video 2? I hope so. We are in Unit 3 now, and we are solving equations. One of my favorite things to do in algebra, so let's play around with it. I like to show you this picture because this is how I think of equations. The equal sign of an equation is like the middle of a balance. And one side of the equation is like what goes in one side, and the other side of the balance is the other side of the equation. I think of it as a balance because we know that these things have to be equal, even though we don't really know what that x stands for. So you might kind of think about it like this, that you know you have 8 little guys in here, and you know that you have 3 little guys right here. But then you have this like mystery bag. What's in the mystery bag? It's called X. And what we're doing is trying to find out what must be in that mystery bag. And it's kind of interesting the way we go about it. So stick with me, and I will show you not only how to solve an equation, but the work that you need to show that tells us that you are really solving the equation as opposed to just kind of looking at it and plugging in what goes in there. In other words, we all see that there must be 5 little rocks in the box, right? Because 5 plus 3 is 8. But if we solve equations that way in the beginning, it makes them impossible to solve later on. In other words, this is the time to learn the method while the equations are very simple. So that when the equations get more difficult, you'll have the method down and you'll be able to solve the ones that are more difficult and you can't solve in your head. So let me show you what I mean. To solve an equation, we need to undo what's being done. For example, look right here, what's being done to x? We say x is being added, 3 is being added to x. And what we need to do is undo that plus 3. So the first thing we did was identify what operation is happening to the variable. Operations are add, subtract, multiply, divide. Once we recognize that it's being added to, we need to think about, oh, how do you undo addition? And if you think for a second, I think you will know that addition and subtraction will undo each other. In other words, if I say plus 2 and then minus 2, I'm back to 0. I've undone it. And multiplication and division will undo each other as well. They are inverses. They undo each other. Meaning this, if I take something and I multiply it by 2, and then I also divide it by 2, I'm back where I started. So take a number like 7. Well, if I multiply it by 2, I get 14. If I divide it by 2, I get back to 7. So dividing by 2 undoes multiplying by 2. Now, how are we going to put that to use? We're going to put it to use right here. As I said, ask yourself, what is happening to the x right now? So we're going to look at this equation and ask ourselves, what's going on with x? Well, it's being added to. See right there where it's being added to by 3? We want to undo that. And we should know that to undo addition, we'll need to subtract. So what I'm really doing over here is I'm going, okay, I'm going to take 3 out of this side of the balance, right? And I'm going to show that in this way. I'm going to take 3 out of here. But if I take 3 out of that side of the balance, you notice all of a sudden I'm not balanced. I'm not equal anymore, right? What do I have to do to keep it equal? Well, I got to do the same thing to the other side. And you'll hear us say that over and over again about equations. We have to keep them balanced by doing the same thing to both sides. What we normally want to do to an equation is we want to undo what we see happening to the x. In this case, it's plus 3, so I'm going to subtract 3 from both sides. And look what happens when I do. Positive 3 and negative 3 kind of go to 0. Don't kind of, they do go to 0. And they're not in here anymore. I don't usually write that 0 in my equation. I usually just leave it out and say, okay, well, what's left is this x. So I'll rewrite the x. I rewrite my equal sign, and then I do the math on this side. Well, 8 minus 3 is 5. So x must be equal to 5. I'm going to keep saying this because you'll make mistakes, but I want to be clear. When you're solving problems for homework and you have a box to type in, I need to see this. I need to know that you know you're subtracting 3 from both sides. It is not enough to tell me x equals 5. I know that your head can plug in and decide that x must be 5 if you're going to add 3 to it and get 8. What we're learning here is this idea of an inverse operation and what do you do to undo something. So make sure you're showing us that in your work. So choose the operation that will solve for x. Again, I want to look at my equation carefully and I want to see what's happening to x right now. And I think I see a 7 in here that's being added to x. What would I do to solve it? I need to subtract 7 because the opposite or the inverse of adding 7 is subtracting 7. And watch what that looks like. I'm actually going to come in and show that on both sides, and I need you to show that work as well. Then we'll actually do the work. 7 minus 7 makes this side, the 7's go away, and x is equal to 9 minus 7, which is 2. So what's the value of x? The value of x is 2. What do we have to do to find that value? We saw a 7 being added in, and we needed to get rid of it or subtract it out. The opposite. How about when something's being subtracted? You see that it says y minus 2 here, not plus 2, but minus 2. So if it's being subtracted from, the way to get that 2 to kind of go away, we say. We don't want the 2 to be on this side of the equals anymore. Remember how we say isolate the variable or get the variable on one side by itself or in one basket by itself. As soon as we get it in a basket by itself, like if we're thinking of that balance, then the other side tells us what it's equal to. If I add 2 to this side, I must also add 2 to the other side. Keep my balance balanced. By adding 2 or doing the inverse of minus 2, I've isolated the variable. I got the y all by itself. It's isolated. I need to do the math on this side, -5, +2. Be careful with your signs. You end up with -3. And I think I went too fast on this one. I think we're going to see another page where I've shown you some more work. So if I'm going to choose the operation that will solve this equation, I see -2, and I would choose +2. I think on the next page, it's going to ask us what's the value of x, and this is where it's looking for us to actually solve it. Y is equal to -3. Remember that both steps are very important for you to show in your work. How about this guy? What's happening to x right now? Choose the operation that will solve the equation for x. So my first question is, what's happening to x now? And I see it's being multiplied by 5. So if I choose the operation that undoes multiplication, I would choose I need to divide by 5. But let me show you how I do that. You're not going to see this divide sign hardly ever in algebra. You never use it. Instead, look what we do. We use this sign, divided by 5 and divided by 5. And I think you will see, I'm going to flip to the next page. Yep. Oops, except for that one has a -5, and I'm going to just hang on to that. So I'll talk about that one in a second. When I see a 5 in front and I want that 5 to go, I'll divide by 5. And look how now I have 1x left, and that's exactly what I wanted. 1x or x equals what I get on this side when I divide 16 by 5, which is 3. So x equals 3. I want to remind you also that you can always take what you think x is equal to and pop it back into your original equation. So if it says 5 times x equals 15, and I think x is 3, then I'll need to check, is 5 times 3 equal to 15? It is, so that's a nice check that I got it right. Let's see what happens if I need to divide by a -5. So in other words, this guy started this way. And I'm not sure exactly what happened here, but I obviously changed the problem in the middle. That's okay. It'll give us both. If it started with -5, note, and it's being multiplied, notice how I need to divide by a negative in order to get this negative sign to go away. So in this case, x is going to be 15 divided by -5, which is negative 3. And I'm going to kind of point that out again. Let me show you a new page, or get you a new page. If I say x plus 5 equals 7 versus x minus 5 equals 7 versus 5x equals 7 and negative 5x equals 7. These are the ones I want to look at because each one has a different thing going on. This one's being added to, this one's being subtracted. This one's being multiplied by a positive, this one's being multiplied by negative. We have to keep our thinking caps on and say, okay, if it's plus 5, I'm going to say minus 5 on both sides. If it's minus 5, the way to get rid of a minus 5 is to add 5 on both sides. That will solve my equation or get the variable by itself. Now watch what happens when it's negative 5 versus positive 5 and we're multiplying. Up here we change the sign because the opposite of adding is subtracting. But down here we want to divide by exactly what we see. So to make the 5 go to 1, I have to divide by 5. And on this side, to make the negative 5 go to 1, I have to divide by negative 5. So this guy gets divided by 5, this one gets divided by negative 5. So I just want to point out, when you're adding and subtracting, this sign does change. So if you do plus 5, you go minus 5. But when you're multiplying or dividing to get rid of something, you want it to reduce to 1. You want 5 over 5 to be 1. And the only way to do that with a negative is to divide by that same negative, so the negative sign goes away. Let's get a little bit more practice. What happens when we get x, when we start out with x divided by 3? How do we undo? What operation would undo being divided? And I hope you say we need to multiply by 3. And I sometimes put 3 over 1 just to make it more clear. On this side, I'll probably just put 3 because I don't have a fraction. But 3 over 1 here is the same as multiplying by 3 here. So if I needed to choose the operation that will solve the equation, I would say, well, I see x being divided, and I need to do the inverse of that. So I'm going to multiply by 3 on both sides. I'm suspecting I have it over here. Yep, with times 3. There's my over 1. Watch what happens when I multiply. I could even do this out the long way if it helps you. 3 times x gives me 3x on top. 3 times 1 gives me 3 on bottom. You didn't really need to do that. I could have said, oh look, those 3's are going to reduce, and I'll just have x left. On the other side, I just need to multiply 6 times 3 to get 18. And if I want to check my answer, don't forget I can do that too. I go back into the original equation. And the original equation was something divided by 3 is equal to 6. So I asked myself, well, is 18 divided by 3 equal to 6? Because I think x equals 18. That's what I solved for down here. And it turns out, yes, 18 divided by 3 is 6. So there's my check. It worked. And I'm good. Inverse operation. Let's see if we can solve and check. Look closely at this first guy and ask yourself the question, what's happening to x right now? What do you see here that you need to get rid of? I see a negative 11. And to get rid of negative 11, I'm going to add 11 to both sides. Whoops, I'm not going to add 10. I don't know where that 0 came from. Let me fix it. Try again. I'm going to add 11 to both sides because positive 11, negative 11 goes to 0, and that's what I'm trying to get to happen. I'm trying to get the x all by itself. That tells me that 14 and 11 is 25, and I might need to check that answer, so let's do that. How do I check it? I go back to my original equation, and that was x plus negative 11 equals 14. I can put in 25 for x and see if I get a true statement. Is 25 minus negative 11 equal to 14? And something about that is seeming, oh, plus negative 11. Sorry, see, I wrote it wrong. there's the plus sign, sorry, plus negative 11. And my check almost turned out wrong, in which case I would have recognized, oh wait, I did something wrong. But what I did wrong was rewrite the equation wrong. It has a plus sign there, and this is a positive and a negative, so the numbers get subtracted, and that works. Let's solve this guy. What's happening to x right now? And I say this guy, let me point to where I'm going. I'm thinking over here. What is happening to your x right now? And the first thing I see is that it's got a negative sign in front of it. We'll talk about that in a minute. It's also being divided by 9. So let's look at it one step at a time. Let's say, well, I see divided by 9, so I know that if I say times 9 and times 9 on this side to keep things equal, put it over 1 to help the math, I know it's going to get rid of that 9. Here they reduce to 1, and negative x is equal to, and how could I write this? I'll say 5 times 9, I can do different things. It's 45 divided by 3 times 1, which is 3. Then I recognize, oh, negative x equals 45 over 3. Well, I know that 45 over 3, or 45 divided by 3, is 15. So I need to reduce that. And here is the very tricky kind of step at the end. So watch carefully for me. Notice that I've solved for negative x, and I need that to be x. The way to think about that is that there's a negative 1 in front of here. And if I divide by that negative 1, is one way to think about it, then I'll get x equals negative 15. And that's the answer that's going to work. In other words, and I'm going to change colors again because I know that last little step is a little bit confusing. If negative x equals 15, then I know I can change both signs and x will be equal to negative 15. And this is what happened down here. Technically, I'm either multiplying or dividing by a negative 1. Mostly what you need to know is don't leave a negative sign in front of the variable. Do change both signs on both sides of the equal sign. So change this guy to a positive and this guy becomes a negative when I change them both. Alrighty, let's see if we can do a couple more real quick. What's happening with this x? And it's kind of interesting. I see two things going on with this x. You may not see it this way, but if you play around in your calculator, I think you might agree. I see x being multiplied by 2 and divided by 3. And I might even write this way just to show you. I could write it like this. See how x is being multiplied by 2 but also divided by 3? It seems difficult, but all I need to do is the opposite of that. So what if I multiply by 3 and divide by 2? In other words, flip it. And I'll need to do that on both sides. Multiply by 3, divide by 2. The opposite of what I see, or the inverse of what I see. Notice how over here, 3 over 3 reduces, 2 over 2 reduces. You can think of it as 6x over 6. But either way, these numbers go away and x is by itself. On the other side, I need to be more careful. I like to reduce first. So 2 goes into 26 13 times, and 13 times 3 is 39. I can check that in my calculator by typing in 2/3 times 39 over 1, and I should get 26. I could even type in times 39. I don't have to put the 1. Simply checking to see if the x is equal to 39. The last one, I think, 4 1/2 is just a weird, or 4 1/5 is just a weirdo. I might well write that weirdo. Remember how we say, I call it the Texas method, because we multiply down here and we add up here, and that's like tx. So multiply to get 20 and add in the 1, and you get 21 over 5. If I need to look at this and decide what's happening to the x right now. And what's happening is it's being multiplied by this 3. It's going to look kind of weird when I divide both sides by 3 because I have a fraction over here. So it's kind of weird to say divided by 3. But that's what we're doing. You can plug that into your calculator, but you can also think about it like this. You know 3 over 3 goes to 1, so you have W left. And I could change this to this sign. This is how I think of it. One of the few times that I use that division sign. It's 21 over 5 divided by 3. And I know from last week that when I divide a fraction, I have to keep the first guy, 21 over 5. I have to change division to multiplication. And then I have to flip the second guy, so it becomes 1/3. Whoops, my writing is rotten down here. What I have is 21 over 5 times 1 over 3. I like to reduce before I multiply. So I'm going to reduce 3 and 21. 3 goes into 21 7 times. And 7 times 1 on top gives me 7. 5 times 1 on bottom gives me 5. X equals 7/5, and you may think, or not X, but W in this case. And you might think, well, that's no fair. It can't equal a fraction. But sure, that's fair. It can equal a fraction. Pop that in your calculator. See if it gives you 4 1/5. And you might even play around with putting in 4 1/5 in your calculator. Remember, you can do it 4 plus 1/5. You can turn that into a decimal, a fraction, however you want. If you don't know how to do that on your calculator, just help. You can do it. Let's see. I said that was the last one, but I wasn't honest. This is really truly the last one. We're going to play with a little negative sign again. But first of all, and I'm just noting that negative sign in front of my variable, but first I need to think, okay, what's happening right now to my variable? And the answer is it has a negative 58 here. So I need to think of adding 58 to make that go away. Let's do that on both sides. When I do that, negative x is left over. See this little guy? He just comes straight down. Positive 58, negative 58 went to 0. And then I have essentially 58 minus 20, which is going to give me what? Like 38? Think about a positive 58 and a negative 20. Do you remember this step? When I have negative x equals 38, I simply change the sign. X equals negative 38. I'm going to leave the check of this to you, but I would very much like you to check it by putting it right back inside there, proving to yourself that this is a true statement. How about when I have minus 1/8? It's like a fraction, and I don't like fractions. So I can still add 1/8 to both sides, and I can let my calculator do the hard part. 3/4 plus 1/8. If you don't like doing that, do it in your calculator. I can see that 3/4 is the same as 6/8, just multiplying top and bottom together. So these two are the same, 3/4 and 6/8. And I said top and bottom together. I should have said multiplying top and bottom by 2. So what I really have here is 6/8 plus 1/8. So I have 7/8. And again, you can do that in your calculator. You can change the answer to a decimal or a fraction. If you need help doing that in your calculator, please let me know. It's an important skill to have. There we go. You should be ready to go practice these equations. I know they are not easy, but I also know that they are going to not go away. We are going to be playing with equations for the rest of the year. So get practice on them, and most important, ask for help when you need it or when you feel confused. Every time you get unconfused about a confusion, you've learned something, so come and get that help that you need. See you soon. Bye.